There.
This picture, right?
Yes, yeah, this one.
There you
Uh,
go.
so the width is 8 meter. The base probably roughly, and then the height, the pitch, 2.7.
Let's call it 3.
Oh, 3. Yeah,
Yeah, roughly, right?
yeah, yeah.
We're gonna do like a schematic kind of
Right,
design.
schematic. Yeah.
Doesn't Yeah, and be this.
哎，大家好。
Hey, oh, la 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 la, ha
Ah,
ha. This is Lee.
Hi Lee.
Yeah,
Hello.
哎，你
yeah.
好。
Hey, good
And
to
this
see you.
is Richard and Zhou Yang, the
Hi.
one at the last. Yeah. Well, he's a foreigner.
An arc in there, just in the corner. Yeah, like that. Yeah, perfect. That's the arc.
So
There.
maybe smaller.
No, no, I think you had. Oh yeah, okay, because of your. Yeah, yeah, you got it. Yep. And then more or less a straight line up to the
Okay,
top, and
whatever. Yeah.
yeah, that's it. That's roughly the profile.
And it's flipped over.
Yep.
There.
Mhm. Okay,
Uh,
so let's make 5 of them.
oh, he's pulling the. Okay. Yeah.
Mm,
50 meter.
50,
50.
Yeah.
50 meters. Yeah. Okay. And then how far apart are they?
0.7 meter apart.
Point 0.7.
Yeah.
Okay. So we'll do them 0.7 apart.
Yeah.
Mm-hmm. Mm-hmm.
Good.
All right. 5. Okay. Okay, so now let's zoom in, and let's in between in the alley,
Okay.
in between. So zoom right in on
Okay.
that, and so what I'm thinking about is we're gonna make like a fence goes right between in the middle,
Oh, fence.
with like a metal fence with
Mm.
tubing.
Mm. Mm.
Mm-hmm.
Um, so what we're gonna do is make an arc from the top of the fence on one side to the top of the fence on the other side, an arc that goes up above the building. It's just upward. Yep, yep, that's it. And kind of right closer, a little closer, but it's an arc, so we just push it down a little bit. That's about right.
So you
I
need
would make it
what?
half meter. Well, I
Half
would make
meter?
that arc. So pull that arc
Yeah.
out
Pull
a
it.
little and make it half a meter at the top. Make that arc like a surface over the top. It's so we extrude that shape, right, as a surface running over the top of the greenhouse. Now what we want is to extrude that horizontally, that top arc, right? And yeah, that's it. And we cover. Oh yeah, beautiful. We cover and we replicate at the end. It's the same, right? At both ends. It's similar idea, of course.
Yeah.
And then the door, yeah, you're
It's
still
around
focusing on the door first, yeah.
The, the door's 2 meter probably. No.
uh around 1.2 meter.
Oh, okay. Yeah.
All right.
Yeah.
Let's
Yeah,
make it
1.2.
let's make it 2.
Yeah.
Make it 2?
Yeah.
Just yeah for schematic. Yeah.
Seems like a good idea. Right. And it has that side walls because it makes a portal
Mm-hmm.
through the bubbles,
Yeah.
through the bubble cavity.
There.
Yeah.
Whew.
All right. Now you see the flow path, right? The bubbles move.
Yeah.
Bubbles move, And the bubble machines are working together, right? They're all in like a circuit, right?
All of the cavity is one channel.
Yes,
Yeah, that's interesting.
in a way they're connected, right? With the flow,
Yeah,
the energy of the flow, the airflow.
right.
Yeah, that's it. 3 smaller fans will fit
Oh, yeah, that's all.
instead of 2 larger. Okay, so now we can turn it any way we want. You know,
Right.
if it goes at that end, why? So that we can push bubbles into the duct, right? And so it goes flush with the inner, push it inward into the duct.
Yeah, move to
It
the
goes,
left.
not there, right? It's there. So it's going to take air from the cavity at the whole building
Yeah,
cavity, right? It's going to pull air.
yeah,
And that's going to help the bubbles to flow in, right? To flow down.
yeah,
Because it's taking air.
yeah,
And it balances the flow.
right.
Because you see, we do have another bubble machine over in the other side.
Yeah.
See? Fans are at the fence. The screen is at the other house.
Yeah,
Okay. So now you see we do have two bubble machines at this end. And that balances the flow. Right? Because otherwise we only have one bubble machine pushing bubbles into these last end house.
yeah.
We can't have that. We always need balance, two bubble machines. So what we move the bubble machine to the bottom here in this case, and we use a duct to send the bubbles to the other end.
Okay.
So the bubbles are flowing toward us, right? Put the big arrow on the top of this end one. Like, see the one arrow you've got? I see it there on the top. Make one there, and it's coming this way, right? It's coming, yeah. And you see the flow is balanced because, you see, yeah, that's the arrow. We can always have the arrows at both ends, you know, because we need to always be checking. So we can have arrows. The arrows are this way, that way, this way, that way, this way, that way, right? We can have them on each end just so we are sure. All right? They go, come this way, go that way, come this way, go that way, come this way. Yeah, we can have them. Yeah, that's it. See, so we're certain about the flow path. Then we can check. When the arrow says it's coming this way, we need to see the position of the bubble machine. That the fan is at the fence. Yeah, that's it. So we expect to see pairs of bubble machines where you see it coming at us. We've got 2 fans at the fence, right? 2 fans there pulling and pushing into the other one, right? So we can always check that. See this one, we look for the fans. Where are the fans? The fans are the first what we see, right? That's the air is coming toward the fan and pushing into the screen. And bubbles are going out of the screen and then down the house. You see, so it's balanced, right? It's completely balanced. There's no out of balance. Air has to flow, and the bubbles have to flow in a circuit. Let's make the top of the roof of the bubble machine red. Then we will really see them where they are. They'd be like dots, red dots. Yep. And we could put an arrow on the top of the on the top of the bubble machine. Let's make like a white arrow, and it's pointing in the direction of the screen. Oh, yeah, okay. Nice. Big arrow. Yeah, yeah. Ha. All right. Can't miss it. Oh, all right, I like it. I like it. So there's the screen. The fan is at the base of the arrow. The screen is at the point, and we just check if the flow is correct, right?
Yeah.
And we can see where each one is, and
First
see
one is here.
the flow is correct, right? Goes that way. So those bubbles go along the duct. They go all the way to the other end, and they're coming out in the right direction, right? And then they go down the house the other direction, right? Because that's where the fans are facing, pulling from, right? So the bubbles will go. Bubbles want to go in and replace the air, right? So what happens is we replace all the air, or in a way we make all of the air into bubbles, right?
All the air, yeah, air into bubbles.
The air becomes bubbles until the last bit of air is drawn into the machine, and it's bubbles. Then the whole system is filled with bubbles, right?
Wow, this is.
And this is basically a laminar flow, so we know it's going to fill completely. It's going to flow down. The air in front is being taken away, right? Making into bubbles so that the bubbles can move, right? Bubbles can't move if the air is not being taken away. The air is taken to make the bubbles, and the bubbles move in, right? So it's the air from one house that's making the bubbles into the other house, right? It's the air from one that becomes bubbles in the other. And we could animate that. We could ask Cedric to do an animation. Of the flow, and then everyone would understand it then. And we see the bubbles flowing along the duct at these very outside.
Wow.
Right? Very outside.
So you are taking the entire canopy into ducts. Wow.
Yeah. It's all a duct-like flow. And they love to flow. They just, there's no resistance,
Right.
They long distance.
Yeah, because there's no bottleneck.
There's no bottleneck. There's no trouble for the flow.
That's right. It is full channel, full. Yeah.
It's not even a U-turn, is it? No, it's not. It just flows until it fills.
Yeah. Yeah.
Well, there is kind of U-turn. Okay, at the very outside side, it is a kind of a U-turn flow.
Yeah.
Right? Down the duct, and then they turn and come in, and they come back.
Yeah.
So that's a kind of a U-turn. But we can do that. I've done that lots of times.
So for greenhouse in the middle, I mean, then they just push almost at the same speed.
Always balanced, right? It's always balanced until you get to the outside side. Then you have to balance it with the duct.
Wow.
So we push the air in, and if the air is full, so somewhere to go?
Yeah, when the bubbles reach the opposite end, the air is gone, right? It's all made into bubbles. And you turn the machine off. Right? All the machines turn off.
Wow.
If you turn on only a pair of machines, you're going to put bubbles into those houses only, right? So you could do kind of partial filling by not turning on all of the machines. Kind of every second machine operating, could make a kind of partial filling. But I would say most of the time, if you're going to put bubbles, you probably put on machines. They operate, together, right? They're working with each other.
Yeah. So total of how many machines?
Yeah. I think pairs of machines, though, can be cycled, like they don't all have to operate at the same time, actually.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
10. Yeah.
10 machines for 5 houses, yeah?
Yeah. That makes sense. Yeah. Huh. Wow.
So that,
They operate at the same time.
well, like I say, you could turn them on in pairs. Like any individual pair could be turned on,
Right. Yeah.
and you would get partial filling,
Partial filling.
partial, and that might be useful sometimes
Yeah.
because you can do it like in a sequence.
Yeah.
So if it's not, it's like cloud, right? You want to, if it's very hot, very sunny, we make the whole roof cool. If it's not quite so hot, and you want to have more light, then you run them intermittently. It's like cloud cover. So you say like it's partly cloudy day.
Yeah, that's right.
Partly cloudy.
Ooh, this is nice. Wow, this is I didn't expect it, I didn't see it because I didn't see the big picture. You see the big picture. You got to see the big picture. Wow, this is much better than
I learned this over 40 years.
Yeah, I know. You see, when you do it, right?
I can't expect you guys to see it in
No.
just a day or whatever because
I know you want to give us a surprise. Oh
Now,
boy, this is so simple
let's
then.
consider though the structure now because we
Yeah.
look at the bubbles, we look at the air cavity.
Yeah.
Let's look again at the structure. So let's go down to eye level, like at
Eye
the
level.
end. Yeah, or the sheets just hang there because the posts are there.
Yeah.
In other words, before I was thinking, oh, we have a closure, we have a panel like on the fence, right? Like a partition. Now we have a partition with like two. Instead of one partition, we have two sheets
Right.
acting as a partition.
Yeah.
And with the rainwater can fall between.
Right.
And those sheets, they just go, like you say, towards the ground.
Yeah.
And yeah, I think like you say, they go to the ground. We can tie them to, maybe there's a bottom rail that we tie those sheets to. So maybe the sheet have to extend. So let's, all the way and tie even sort of so that the bubbles can't get, to the other side, right? We don't want them to escape over to the other side. They have to flow down the house all the way to the end. If they have an opening, they might reverse into the other house beside. So before we had one partition on the fence to keep the bubbles separate, and now instead of one we have two, right? Two sheets instead of one sheet. And that's not bad. That's a small price, right? To make it work very well. These materials are very cheap, right?
Yeah.
Yeah.
Then the problem with the fan connection, you see.
Well, we just make an opening in the sheets and a
channel, a collar.
Yeah.
Collar, yeah.
Make a collar yeah. Some kind of
connection.
Coupling. We couple.
Yeah.
Coupling that allows the inlet of the fans. And actually, only thing we need is the inlet of the fan.
Yeah.
To be coupled.
That's right.
Yeah. That's what pulls.
Mm-hmm.
Everything else is not really coupled. There is a frame at the front face, though. Okay, we need a frame there.
Front face.
Yeah, right at the
the
where
door?
we see the white face there. Right? When we rotate that and rotate looking from above and so on, you can see that you need like a frame there.
Yeah,
right?
this is
That's a frame.
Yeah.
So there's a frame at the end walls.
Yeah, that's what I'm talking about. Yeah.
Yeah, there is a frame there.
Right.
But there's no frames going down the length, right?
Right. Yeah. Okay. Yeah, makes sense.
And the rest is air supported.
Yeah, making sense. Yeah, that's good.
And the cover comes over everything, drops down over.
Yeah.
I think. We'll have to look at, as I say, more details, right? Because how that cover really installs once we've got the concept of it, and look at the bubble machine and look at the fence details more carefully.
Yeah.
I mean, on the outside, we're going to see the fence is on the outside, so the cover is in the inside of the outside side, right?
Mm-hmm.
The outside side.
Yeah, that's right. It
The
because
fence.
we use the rope edge to tie onto
The tie, and the rope edge is on the inner of the fence there.
Right. Yeah.
You're going to see the fence as being the
guide,
final
the guard.
outer guard. Yeah.
Yeah,
In fact,
guard.
it's kind of a fence around the whole structure in a way.
Yeah.
At least along the walls there, the outside wall.
Yeah.
So we call it the outside wall.
Yeah.
The others are inner side walls.
Yeah.
Right? Outside wall is only two of them.
Yeah, two of
Then
them.
Inner side walls.
Yeah.
That come together and make the gutter for the rainwater, keep the bubbles contained in each house so that bubbles flow, one this way, one that way.
Yeah.
See, because if there's any way for them to cross over, they would.
Yeah.
They would like short circuit, right? The flow path.
Mm. Wow.
So you have to keep it partitioned, and when we consider the rainwater problem, the only easy way to do that is to make each cover, completely independent, right? Each one.
Yeah.
Then the rainwater goes between.
Yeah. That's right.
Into the gravel.
Yeah.
But that's a nice way to modularize the fabrication anyway.
That's right. Yeah, it's easier. They just make the same thing, right?
Yeah.
And then
Yeah, and they can fold
and you
it,
can cut the hole to make the connection to the to the collar, bubble collar, on site.
Yeah. That's right.
Good.
I think that should be on site. And see, the people have to go into the bubble cavity to do some of that work.
That's right. Yeah.
The cavity is a half a meter at least thick, so no problem.
Yeah. So that when can we have a zipper, some entrance, right?
For a zipper entrance into the bubble cavity.
Yeah, at the door maybe somewhere.
Yeah. A door, whatever. Yeah. And the door can be right at the main door, where
that's
on
right.
The side wall, you just have like an opening that you can close. And
that's right. Yeah. You walk in.
Bubble cavity.
Wow.
Yeah.
Oh, this is nice. Oh yeah, right.
They're going to have a much greater capacity for cooling, and then we can also, if it's a new construction, we can get into gravel beds. And
that's right.
The geothermal.
Yeah, geothermal. Yeah.
Yeah.
Mm-hmm.
Even someone that actually might even have an existing greenhouse, if they understand the geothermal, they might say, "Oh, I will put some geothermal."
Yeah, they can. This structure frame is very light. They can move to the side and dig. Right?
Or just go in and dig and
then just put it back.
Even doing one, like say the center one, as a geothermal connection.
Right. Yes.
Could be an advantage, right?
Right.
To the whole operation could be
Mm-hmm.
enough.
Yeah.
You have geothermal connection anyway, right?
Yeah.
The earth is there, and we could put the soap liquid in, tubing in the ground in any of them without doing any gravel.
Yeah.
And that will connect to ground temperature.
Yeah, that's right.
So without so much,
yeah, that's right. Mm-hmm.
That's less cost, right, and less disruption.
Yeah.
To put our soap piping,
mm-hmm.
Which would be a sealed pipe, and just put it in the ground.
Yeah.
To have more heat exchange.
Yeah. So maybe pick the central location of the center. I mean, the middle.
Yeah.
Middle.
If you just had one 4-inch diameter pipe, all along the length of the building, it's a lot of soap liquid.
Yeah.
So you drain towards one reservoir.
Yeah. That's
and
right.
you pump, towards the bubble machine. I
Right.
don't know. You've got those things to think about as well now.
Yeah.
Where did the reservoir? Where do we drain?
Right. Whew. Okay. Should we call some? Yeah. Maybe we can just explain this to, yeah, and I get the file and explain it to Lee in Chinese,
Yeah.
and then he get the whole idea how it works, right? And
Yeah,
then he decide whether to go further, right?
well, Aubrey, maybe what you could do is, you make those beautiful videos. Now
Yeah.
you have 3D, you
Yeah.
have the 3D environment. You can kind of,
Yeah.
explain it and walk
Yeah.
through.
Yeah.
Young can put, more whatever details or things that are needed.
Mm-hmm.
But we got the arrows, we got the, flow path. I mean, the only thing that would enhance this even more would be an animation of the bubble film.
Yeah. Make the end walls transparent also, the white
Yeah.
part, so I can
Yeah, that's true.
see, explain, and then just explain how everything flow.
Yeah.
Because that's important. Then he see that, okay, it's better to do this way, right?
Yeah.
If you just do one, individual, just use one individual to do it, then we have to do it differently, right? But if you do it this way, convert 5, right, at the same time, then this is actually easier.
Oh yeah, yeah, because you do need this flow. Now, if you only have one house,
only
then
one.
you can use like we do the outside houses.
Oh right, yeah. So one bubble machine at the corner, and then the other one at the diagonal corner, right?
Yeah, and 2 bubble machines, they push the bubbles to the opposite end, and then they come back.
Right.
Come back over the roof.
Yeah.
Yeah, to come back to the bubble machine. I think that would be a good way, because, like we say, it's better to push the bubbles than to try to pull air, which can, if it's a duct.
Yes. Yeah.
Duct is going to want to, collapse,
Mm-hmm.
the air movement.
Yeah.
And so pushing the bubbles to the opposite end, and then they've come back to source, right?
Yes.
Flow back.
Yeah. Wow. Whew. So when you turn on all the fans at the same time, so everything moved at the same time, right?
Yeah. You'll see the roofs filling like this. See the bubbles? You'll see opposite, toward the opposite ends.
Right, yeah. Move this way, yeah.
That's why I mean, like, an animation could be really helpful for people to see exactly what we're talking about.
Right.
Bubbles, how the air is disappearing as the bubbles are made, right?
Yeah.
We're taking the air from one panel to make bubbles into the adjoining panel. And it would be very interesting. So you go back and look at my, bubble patents,
Yeah.
and you'll see the circuit flow.
It's here, right?
Yeah.
Oh,
you can go to the drawings.
No drawing. Images. Oh, they separate.
Yeah.
Oh.
9. There's 9 pages. Yeah.
Oh.
Of
this?
Yeah.
This is the one, right?
Yeah. See the circulating flow.
Ah, yeah. Okay. Huh. It's everything is there.
Yeah.
Boy.
And there's more examples as well.
More examples. There's only one page.
No, there's 9 pages. I'm sure there were other drawings.
At the bottom, full pages.
Oh, full pages. Okay.
Oh, okay.
Oh, there.
Yeah, there.
There's more.
There. Okay.
There we go.
Okay, I see.
Different ideas, right?
This is the wall.
Go around the wall, go around the roof, go in long channel, have bubble machines at different places in the channels.
Wow, look at this.
A tubing arrangement, any kind of envelope, right? Of a that you can fill up with bubbles.
Wow.
So,
It's all there.
yeah, my claims are very broad because.
But I mean, I thought, slightly you develop, right? Making better. I mean, bigger scale. But now, I mean, in the pattern is you have it all.
This is still extremely broad definition of the process.
Yeah, but I mean, you went such in such a detail. I mean, I thought it's just a general idea.
No, a patent has to be very specific, and my claims are very broad. So meaning no one can come into this area.
Yeah, look at this roof, the wall, and the bottom. This is kind of could be the floor, right?
The floor, the reservoirs.
Yeah, I mean the whole building could be built this way.
Yeah.
Right.
And different shapes of bubble cavities. So
yeah.
Without going into.
Well, this is better floor heating. I mean this, right? If this is floor,
It could be any kind of cavities,
Yeah.
Filling with bubbles, yeah.
Because the floor between levels, is very thick.
The main thing is the process of the recirculating path. You see, that's what I've patented.
Yes.
The is in the pathway.
And this is the secret. Yeah.
Yeah. That's it.
Yeah. Ooh.
So we don't take any air from outside. We use the air in the cavity.
I never look at your pattern.
The key idea is, you see, and there's different shapes of bubble screens. You see, there's a rectangle one.
Yeah.
And then I have circular ones. I have different
circular ones,
square one, and whatever it needs.
Yeah.
To follow the principle.
Yeah.
The principle of filling the entire cavity because of a circulating pathway.
Wow. Okay. Ooh.
Yeah.
This is interesting.
And I think this is better than the passive solar greenhouse.
Right? Oh yeah. Better. Yeah.
Yeah, and then we don't have to fight with those people who say they have a solar greenhouse, and they're going to say, well, ours isn't as good as theirs, and so on.
Oh yeah.
We just do this,
That's right.
And everybody's going to say, well, is it a solar greenhouse? Yeah, well, of course.
So now we know the shape doesn't matter, right? You don't have to be that kind of shape, because you have, as long as you capture solar energy and then store it, right?
Yeah.
Yeah. The ground, right? Don't spend time with the wall. The north wall is the ground that is actually played a major role.
Definitely, you have that huge footprint coupling you to the ground, and then you've got the sky above and the ground below.
That's right. Yeah, it's the heaven and earth. Yeah.
Yep.
Yeah. It's the sun and water.
And the water between.
That's right. Water in between.
Which is exactly our logo.
That's right. Yeah.